This is a presentation I gave at the Wild Things Conference in the Chicago area on February 25th, 2023. I am redoing the narration since it wasn't recorded. Incidentally, this was a great conference with about 2,000 people in attendance. Most herbicide spraying technology has been adapted from agriculture. In agriculture, precision herbicide application is not important because genetically modified herbicide-resistant crops can be sprayed with herbicide without harming those crops. Native area management is different. The desirable native plants, of course, are not herbicide resistant. Anytime we use herbicides in a natural area, the focus must be on keeping that ecosystem thriving. This means avoiding spraying any of the native species in that ecosystem. Remember, native plants are not easy to replace. They live a long time. Native grasses can live almost 40 years. This makes them very valuable. My company's name is Green Shoots. We develop and sell precision herbicide application technologies. I will talk about some of our systems today. However, for the most part, what I have to say has relevance to any system you use to apply herbicides. In terms of protecting native plants, when using herbicides, there are 4 key factors. First, targeting just the weed. Second, keeping the herbicide on the weed. Third, enhancing uptake by the weed. And fourth, enhancing translocation to the proper sink. What I have to say mainly focuses on glyphosate, since that is an herbicide commonly used in natural areas. However, I will also discuss some other herbicides too, such as triclopyr. Let's look first at targeting just the weed. This quote is from a study by Pimentel. It is pretty astounding and troubling that only 0.1% of pesticides reach their target pest. I haven't seen any recent studies that might update this number. However, with the prevalence now of herbicide-resistant crops, that percentage may only, unfortunately, have decreased. Why so little? A big factor, I believe, is that agriculture uses high-pressure spray. As pressure increases, drop size decreases. This is true for all nozzles. And small drops, of course, are more drift prone. This reduces the ability to target. Native area management often uses backpack sprayers. Although they are smaller than most agricultural sprayers, they are still using high pressure. For example, this backpack sprayer can produce 150 psi and has a recommended working pressure of 15 to 80 psi. That's still high pressure. There have been a few studies related to drift from backpack sprayers. One demo really drives home the point about the potential for off-target harm with backpack sprayers. It was done by one of the guys from a website called Sprayers 101. These are 2 experts on herbicide spraying from Canada. Their website mainly focuses on agricultural spraying, but it's very instructive for anyone who sprays weed killers. In the demo, one of the Sprayers 101 guys, Jason DeVoe, and a research assistant did a video showing indoor experiments on herbicide drift. He used a backpack sprayer and sprayed straight down. He placed pots at various distances from the nozzle with water-sensitive paper attached to the pots. He sprayed under various conditions as shown here, including no wind. The results were that spray drops appeared on all the water-sensitive paper pieces in every round of testing, even at 25 feet from the nozzle. The result of this demo is pretty stunning. A backpack sprayer at 50 psi can produce a 50-foot wide spray band in no wind conditions. And remember, out in the field, you won't be able to see those small drops in what I call the shadow spray band. However, that shadow spray band puts nearby desirable plants at risk. This is especially true if you spray multiple weeds near a desirable plant. In summary, agricultural spray technologies, simply put, are bad at targeting just the weed. They offer no precision. Of the 4 factors, this is where the traditional ag model performs the worst. What about keeping the herbicide on the weed? How does the traditional agricultural spray model perform? Actually, much better. The small drops produced by high pressure spraying do stay on leaves better than large drops. One note, bear in mind that rain coming after spraying herbicide can rehydrate the herbicide. If this occurs, the herbicide can easily be washed off the target weed. I'll talk more about preventing this later. In terms of keeping herbicide on the weed, therefore, the traditional agricultural spray model does a pretty decent job. What about the third item? Enhancing uptake by the weed. Many factors affect uptake, but let's focus on these two: humidity and herbicide concentration. Humidity is something that has received more and more attention lately when it comes to herbicide applications. Simply put, it's better to have more of it. How does humidity affect uptake? Fog and rain cause leaf cuticles to swell. The increased humidity opens pathways through which agrochemicals can be transported. Those pathways are thought to be cellulose-based. By hydrating those cellulosic pathways, water-based herbicides can penetrate leaf cuticles. If relative humidity is increased from 70 to 100%, shown here found that glyphosate with surfactants penetrated 5 to 10 times faster. That's a pretty dramatic improvement. The other factor that we'll focus on is herbicide concentration. With glyphosate, it's better to have fewer, more concentrated drops than to have many, more dilute drops, even at an equivalent total quantity of applied herbicide. With its smaller, more dilute drops, therefore, the traditional ag model of application doesn't do so well here. How concentrated should the weed killer mix be? I will talk more about that later in this presentation. Therefore, the traditional ag spray model with its small drops doesn't do that well at enhancing uptake, especially with glyphosate. What about enhancing translocation to the proper sink? How does the traditional agricultural spray model perform in this element? Many things affect translocation. Let's look here at two critical factors: herbicide concentration and the season of application. As with uptake, translocation of glyphosate improves when you spray concentrated drop. Now let's look at the season of application. Herbicide labels often recommend that the herbicide be applied to actively growing weeds. Research indicates that this is good advice for annual weeds, but not necessarily for perennial weeds. Why is this? To kill perennial weeds, you generally want to apply when sugars are being moved to underground sinks. For example, down to rhizomes and roots. In the spring, plants, of course, are very actively growing. However, sugars are moving to above ground sinks, and very little of the herbicide will be distributed to below ground sinks. Similarly, in the summer, sugars are typically moving to reproductive organs like flowers and seeds. Less herbicide will be distributed to underground sinks. Finally, after flowering in late summer or fall, sugars are moving to underground sinks. Although the plant foliage is growing the least at this time, it is often the best time to apply to perennials. Thus, the label recommendation should be changed to read that perennial plants should be treated with foliar applications when foliage is green and storing carbohydrates in below ground sinks. In summary, with translocation, the traditional agricultural model doesn't work so great with glyphosate because of the small drops created by agricultural sprayers. In addition, you have to ignore the label advice on the time of year to apply. How can weed control be improved for natural areas? Let's look first at targeting the weed. This is the area where the ag model performs the worst. A big way to increase targeting of weeds when spraying is to lower spray pressure. This has two effects on the spray. First, lower pressure reduces the size of the shadow spray band. All nozzles have a specified angle of spray, such as 80 or 110 degrees. However, higher pressure increases that angle. We have shown that with our own testing, and the Sprayers 101 guys demonstrated that with their demo. By lowering pressure, you can reduce the size of the shadow spray band and lower the chance that the shadow spray band will hit valuable nearby plants when you are spraying with your backpack. Second, lower pressure produces larger drops which are less prone to drift. Besides lowering the pressure of your sprayers, there are other ways to more radically reduce off-target harm. One way is with the direct application of herbicides to weeds. All of our products can be used for direct application. Here, for example, I am dispensing foam herbicide directly onto the leaves of a Canada thistle rosette using our small foam dispenser. Here is an application to a cut stem of an herbaceous plant. In these images, I'm applying foam herbicide using our large foam dispenser with a mesh brush attachment. This image shows a foam foliar spray application to Japanese knotweed being done by the Minnesota Department of Agriculture. This is a drizzle of foam herbicide onto knotweed. Targeting just the weed is probably the most important modification to traditional ag spray techniques. This is where the biggest strides can be made in protecting native plants. Lower pressure spraying will reduce the size of the shadow spray band. Also, lower pressure will create larger drops that are less drift prone. And to eliminate drift entirely, consider direct application methods such as foam wiping. Let's look next at keeping the herbicide on the leaf. As mentioned, large drops produced by lower pressure do not stay on leaves as well as small ones. However, this shortcoming of low pressure can be mitigated. First, lower pressure reduces the velocity of spray drops. Lower velocity drops are retained better on leaves. Second, surfactants can help larger drops stick better. Instead of bouncing off a leaf, the drop with added surfactant sticks. Adding a surfactant can dramatically reduce drop bouncing, as research has shown. Dong found quite significant improvements in reducing drop bounce when surfactants were used. You can see why this might occur in this slide and the next. This slide shows an application of glyphosate at 10 psi and an application at 30 psi without any surfactants. The drops are very distinct in both. The ones at 10 psi are smaller than the drops at 30 psi. With added surfactant, however, the drops are no longer distinguishable, and the spray film on the leaves look very similar at both pressures. There are still other ways to keep herbicides on foliage. Unlike spray drops, foam can really cling to foliage surfaces. As mentioned, rain following an herbicide application can rehydrate herbicides. Rain is a potential problem for all types of herbicide applications. There isn't much research on this. One of our users of our product likely documented this phenomenon. This was an application of foam herbicide to reed canary grass, visible in the lower right. Rain occurred after this application and likely caused herbicide to rehydrate and splash onto some nearby desirable native plants. The obvious advice is to apply herbicides when rain is not expected for several days. However, that can be difficult to do. Other things you can do are use direct application techniques such as applying foam nearer to the ground beneath the plant canopy, where there's less chance for the herbicide to drip or splash onto desirable plants. Protected by the leaf canopy and near the ground, this herbicide application is less likely to splash onto nearby natives. Also, with tall weeds near desirable plants, you can bend, but not break, branches of the weed toward the ground and away from the desirable plant, like I did with this knotweed. By doing this, you can reduce the likelihood of herbicide dripping or splashing onto nearby desirable plants. You can also cut stems of tall weeds and apply foam herbicide to the cut stem. If you leave a few leaves on the stem, those will protect the herbicide after most of the herbicide has slid down the stem of the weed. Thus, with modifications to the way you apply herbicides, such as spraying with a surfactant in your herbicide mix, you can help keep applied herbicides on the weed. In addition, you can apply to parts of the plant that are more protected, or modify the plant and treat, for example, a cut stem. These are all ways you can help ensure that applied herbicides stay on the weed. Now we move to the third item, enhancing uptake by the weed. As mentioned above, with glyphosate, having more concentrated drops improves glyphosate uptake. Therefore, the larger drops produced when you lower pressure of your sprayer should help with uptake. How concentrated? For most foliar applications, between 2 and 4% active ingredient. For other chemicals like triclopyr, probably a little lower, say 2% active ingredient. As mentioned, increased humidity enhances uptake. One good thing about foam herbicide is that it will stay hydrated longer than spray drops. We did experiments comparing drying time for sprays and foams. The foam took more than twice as long to dry out as the spray. Keeping that herbicide application in an aqueous form and keeping that humidity high will enhance uptake. Do certain parts of the plant absorb herbicide better? There isn't much research on this. One study from the 1950s suggests that 2,4-D was absorbed better at the midrib on bean plants. These photos show application of a concentrated glyphosate to Bohemian knotweed near the midrib of a leaf. It's interesting to note that the herbicide seems to have scorched local cells in the brown spots. This could be bad for uptake. However, tissue near the midrib still appears very viable. In these images, produced in a study by Arsic and colleagues, you see a cross-section of a leaf with staining of the portions of the leaf that have taken up phosphorus from a foliar application. Above the red arrow, you see the midrib as a hotspot. In addition, there is a connection between the midrib and the vascular bundle via the bundle sheath extension. This research suggests that applications of herbicide to the midrib might be good for herbicide absorption. Based on this research by the Arsic group and Crafts, perhaps the midrib and petiole are good places to apply herbicide. Another area you might want to apply herbicide to is the stem of herbaceous plants. One study found that cotton plants absorb more glyphosate applied to stems than to leaves. Therefore, with adjustments to our applications, we can maintain or even improve the amount of herbicide taken up by the weed. A low-pressure spray with big drops should improve uptake. Think also of ways to increase humidity or the wetness of the leaf. One way to do this is to use foam, which can take twice as long to dry as a spray. Finally, you might experiment with directing your application to certain portions of the plant's foliage, such as the midrib, the petiole, or the stem. Finally, how do we improve translocation? The first step is easy. Do more foliar applications in late summer or fall when perennial weeds are actively storing carbohydrates in below-ground sinks. For frost-sensitive, non-woody, i.e. herbaceous perennial weeds, you have to be conscious of the frost. For invasive knotweed, I wait until after flowering. This also protects bees that might be foraging. Bindweed and crown vetch are two other frost-sensitive perennial plants. Treat them before a killing frost. Some herbaceous weeds tolerate frost pretty well. I have treated Canada thistle after temps have dipped to the high 20s Fahrenheit. Woody perennials are another matter. For these, you can do cut stump treatments and other kinds of cut surface treatments. Some, like Tree of Heaven, should be treated in late summer after flowering and seed production. Tree of Heaven sprouts from its roots, and one may be able to generalize that root-sprouting woody plants should be treated shortly after flowering and preferably not in late fall or winter. With most other woody plants, you can treat them anytime in the fall or in winter. Obviously, these woody plants are not actively growing at this time, but cut surface treatments work well. I like to treat woody plants in late winter after the snow has melted a little, so you have good access to the base of the tree or shrub, but before buds start to swell. Generally, this is when there are still cold nights. Besides the timing of your application, the second thing you should do to enhance translocation is to use a concentrated application of glyphosate. You can see how well concentrated applications work in these slides. Here, just a small dollop of foam herbicide is enough to kill this thistle rosette. Or a small amount of foam herbicide placed on the crushed stem of crown vetch kills that crown vetch. And foam weed killer applied to the live inner bark around the circumference of the cut stump of a buckthorn tree yields a very good application. There is also some research about how well low volume, high concentration applications work with other chemicals other than glyphosate. I wish there were more. So let's do a quick review. How do we improve performance on these 4 aspects of weed treatment? In terms of targeting just the weed, this is where ag techniques perform the worst. If you lower the pressure of your sprayer, you can spray bigger drops, which reduces drift. In addition, and this is something missed by most research, lower pressure can reduce the size of the shadow spray band. This means less direct spray onto nearby desirable plants. Finally, there are direct application techniques like foam wiping that can entirely eliminate off-target applications. In terms of keeping herbicides on the weed, conventional ag spray techniques do reasonably well. So can alternative application techniques. Lower pressure reduces drop velocity, surfactants make bigger drops stick better, and foam herbicides can stick really well to plant surfaces. Now let's look at the third item, enhancing uptake by the weed. Use low volume, high concentration applications of glyphosate. Keeping herbicide in an aqueous state for as long as possible will enhance uptake. Foam herbicide is one way to do this. You might also experiment with targeting certain locations on the plant foliage, such as the leaf midrib and petiole, and the plant stem. The fourth item, enhancing translocation of the herbicide in the weed. With regard to this, the guidance is very similar to that for improving uptake. Use concentrated drops. One additional aspect is timing. Users should try to apply to perennials when they are actively storing carbohydrates in the underground sinks, and this will usually be in late summer or fall. If you have a comment on this video, please add it below. I try to answer every comment, and it helps me and others learn more too. Also, we always appreciate it if you'd like this video. If you want to see more of these videos, then please subscribe to our channel. Most important of all, get outside and go to a natural area. Even if you live in an urban area, there should be many near you.